Welcome back to our series on data handling for statistics. I'm Mark Ledbetter, and this is lecture video 8, and we are going to continue with basics, and I believe this is basics 4. Yes, basics 4, okay? So we're going to pick up where we stopped last time. Last time we were talking about vectors, and we talked about that recycling rule, which is quite confounding the first time that you come over it, across it. But once you know about it, it makes sense that if something strange happens, you know how it's happening now. Okay. So let's start talking about matrix operations. Now the first thing is I don't expect you to already know any of this, and I don't expect you to be a whiz at matrix calculations. I don't even expect you to know how to do matrix multiplication or how it works. I'm just going to go over it, and then we will have it, okay? I also don't expect you to know how to do inverse matrices, etc. All right, so if you don't understand how to do this, don't worry about it. There are many resources out there that talk about how to do matrix calculations, okay? But I want you to know how to do these things in R, okay? There's going to be a lot of things we talk about this semester that you don't understand yet. We're going to talk about some statistical procedures and methods and stuff, and we'll talk about how to do it, but we won't talk about what it means or how to interpret it or any of that, okay? So we're just going to go over the code so that when you take a course that requires you to do this, you'll have the code, you'll have some knowledge of it, you know where to go to get that information, okay? So let's go ahead and get started with matrix operations. We're going to do very basic stuff in this video. The first thing is subtraction, addition and subtraction. So I am going to create some matrices here based on random numbers. And anytime we're doing anything in statistics where we're doing research, we want our work to be reproducible. In other words, I should be able to give you my code and you can come up with exactly the same results. So even though I am quote unquote randomly selecting these numbers, I will tell you that there is absolutely nothing that is truly random in a computer. It just is so it just seems so random that that you wouldn't know the difference. But we call them pseudo. Pseudo means false, by the way. Pseudo random number generators. So pseudo random number generators. Okay, and so what we're doing is we're setting the seed tells us this to a certain starting point in this as close as we can get it random sequence of numbers. Okay, so if we tell it 1586, then every time it performs whatever we're doing, then it will give us the same value. So I'm setting the seed, and I just chose 1586 just kind of out of the air. And then I'm going to create this matrix. And in this matrix, let me do some parentheses here. Okay, so in this matrix, I am sampling 25 values out of the numbers of 1 to 100. So I'm creating a sequence of numbers, 1 to 100. And out of those sequence, so 1, 2, 3, all the way up to 100, I'm going to choose 25 of them with replacement. So I can have the same values more than once. Okay. If I put replace equals false, then they'd have to all be unique values, but they don't in this case. So the sample function is going to say I'm going to, each number, 1 to 100, is going to have the same probability of being selected, so that'd be 0.01 in this case. I'm going to choose 25 of them, and every time I choose a number, I'm going to put it back in the pool so it can be chosen again, but randomly so. And then I want this to have 5 rows, 5 columns, and I'll set by row equals false. I could set it to true, but then I'd get a different matrix. So let's let's all do it the same way. By row equals false. Then we're all going to get the same matrix. Okay, so I do that, and then I print out xmat. And you can see I've already printed it here. 93, 39, 99, 29, 73. You can go through 46, 2, and you can see that it's identical, and you should get the exact same one if you use this seed first. Okay, so here it is. Now, note the positioning here. When I copy this, what I did was I copied from here down. And so when I copied, you'll notice where the bracket here is. This side of the bracket, this bracket is lined up with the right side of the numbers. But that's not happening here. Okay, so I'd have to tab and back up one. Okay, and now I've lined it up because this stands for all rows. The blank here before the comma means all rows, and this means it's column 1, and this is column 2, and this is column 3. The second number is the column. The first number is the row. And it's saying row 1, all columns here because it's blank. Okay, row 2, all columns. Row 3, all columns. So the entire row. And this is the entire column. That's what this is saying. Okay. So there's a way to get around this. If we just copy the result, so if I come down here and instead of starting up here with the caret, if I start with the output here, okay, and see if I can make it, I can't get it down, okay, so I start here, and then I copy. Now, when I paste here, instead of pasting yet, the first thing I'm going to do is Control-Shift-C. So I've put a comment there. Now I paste, and look what happens. It lines it up right, and then I can comment out the other rows. And now it's lined it up perfectly. Okay. So I hope that is a nice little trick to help you get your stuff to look nice so you don't have to fiddle with it. Okay. So you don't have to copy this here anymore, just the output. Okay, you don't have to include the caret where the commands are, just the output. And so if you, I'm telling you that you can do that so that you can make it line up nicely. So just by doing the comment first, it puts the space in there. If you don't do the comment first, then it leaves it right there, which is not where you wanted it. Okay, all right. Now, so YMAT, so this is a Y matrix, and so I'm going to do the same thing with this. And so I've done the same thing. I've got sampling, but now instead of 1 to 100, it's 1 to 200. I'm still choosing 25. I still want replace is true, and I still want 5 rows, 5 columns, and I'm going to do by row equals false still. So again, this was just a choice, and that choice needs to be the same each time. Well, it doesn't matter between X and Y in this case because I don't care what the numbers are. I just want the numbers. But if you want the same thing as me, this needs to be false in both cases. Okay. So I'm choosing that YMAT, and then again here I'm just gonna copy Y, not X. So I'm going to start here and copy, and then up here Control-Shift-C, and now Control-V, and then here is my Y matrix. I like to have the matrices where I can see them so that if I'm going to add these, what's going to happen is I'm going to add this element with this element with this element. So the corresponding this element with this element, and so forth. So that, this element. So the corresponding elements get added. If I'm subtracting, then whichever one is first, the corresponding elements from it, it's that one minus the other one. Okay? So here is X plus Y, X matrix plus Y matrix. Here we go. So this was 93 plus 65 will be what, 158? Yep, and here's 158. Okay? And so we copy this, oops, get all the way over, Control copy, Control-Shift-C, Control-V, and then I can come up. I don't have to have the whole thing highlighted, Control-Shift-C, and it does that. And now I want Y matrix minus X matrix. And here is the result. So, So I'm going to take y 65 minus 93, 31 minus 39, 80 minus 99, etc. Here's 164 minus 24, okay? And so that's what I end up with here. Control copy, Control C, and then tab, Control Shift C, Control V, enter. Oops, don't want to be on there, but just any part of it. Control Shift C, and now I have my nice matrix. Okay. So we add or subtract the corresponding elements. So these matrices, they don't have to be square, but they have to be the same dimension. So for addition, subtraction, matrices have to be exactly same dimensions. Okay? Or else you can't add or subtract them. All right. And I haven't tried this with R. Maybe it does. Maybe it will let you if you do that, but then it's going to have to use some recycling rule. So that might really be messy in this case. Okay. So now let's talk about multiplication. This is matrix multiplication. A vector is just a matrix with one column. Okay, a single column. So the matrix dimensions. Let's talk about matrix dimensions. I thought I had actually I talk about that later. Yep. Okay, so we won't yet. All right. So we're going to say that these are n by 1, where n is the number of rows and 1 is the number of columns. So this is the number of rows, this is the number of columns. So if it's a vector, it only has one column. Okay. So when we perform vector multiplication, sometimes we want the dot product of the two vectors. That means the matrix multiplication, not just the multiplied elements, which is what we were getting with the asterisk. And so the multiplication operator for the matrix is this. It's a percent sign, then the asterisk, and then the percent sign. Okay, so that is the new operator. That's the operator for matrix multiplication. So I want to take x1, x and x1 that we had before. So that means I need to go get x and x1. So sorry, you won't have to do this. I'll put this in the, let's see. I want to find x and x1. Is it in here? Nope. So recent projects, was it files, was it in 7? Let's see if I can find, yep, x and x1. So I'm going to paste that in the top of this one so that you don't have to, or actually I'm going to paste it here. So we can use the same vectors that we had before. And so we want to multiply, actually I'm going to move these over. Okay, so we want to multiply x1 and x and x1, and they have the same length, but we want to, so what we're really going to do is we're going to multiply the transpose of x times x1. So remember that these are columns. Vectors are columns. They go up and down. So I really think of this as a column of 12.5, then 4.2, then 2.2. So in fact, I can write this way. So if it helps you to visualize this, this is what they really look like. Okay, they're a column of numbers. So if I want to multiply x and x1, I can do x prime or x transpose. That's where x is now written as a row, and then x1 stays a column. Okay, so so here is what we have. I have x prime, x1 is now, so the transpose of x is going to be written as a row, and then I have x1 here written as a column. And so what we do is we take the first element of x transpose times the first element of x1, then we add it to the multiplication of the second elements, and then add the third elements multiplied, and then the fourth elements multiplied, and then the last element multiplied in this case. Okay? So we multiply each of the elements, but then we add them together and we get one number. When we multiply vectors with matrix multiplication, we get one number, or the dot product, if you will. Okay? So let's do that in code. Here it is. Okay? And you see, here it is. So, yeah, so I don't need this. So if I come down here and grab this here, Control copy, I'm going to come back to here, Control delete, so Control Shift C, and then Control V, and then Control Shift C for that last line. This is what I get. So I get one answer, but it's in a matrix form. If I say, what is this? It's a matrix. Okay, it's a matrix with one row and one column. It's a 1 by 1. Okay, so the answer is given to you as a matrix. The class of the answer is another matrix. Okay, so when you multiply matrices, your result is a matrix, always. Okay, so now the other thing I can do is I can write this as the transpose of x. So t of something is t, the function t, is the transpose function. Okay, so it will transpose a matrix or a vector. And x is a vector, so it treats it like a n by 1 matrix, and it transposes it, makes it a row like this. Okay, and then times x, and then I've summed it. Okay, so if I do this, guess what? I get exactly the same answer, except it's not a matrix anymore. It's just a vector. Okay. Okay, it's a vector. Now let's talk about matrices. So first you need to know about dimensions of matrices. A 2 by 4 matrix, again, has 2 rows. The first number is the rows, and the last number are the columns. So 4 columns. So 2 rows, 4 columns. To multiply matrices, the number of columns of the first matrix has to be equal to, has to be identical to, they have to be the same, that's what this means, the number of rows of the second matrix. So if I have a 2 by 4 matrix, I can multiply it by a 4 by anything. Okay, so this number and this number have to be the same. And then the result is going to be the first number by the last number. Okay, that's the way it works. Okay, so let's create a 2 by 4 matrix. 2 rows, 4 columns. With the first row, the odd numbers 1 through 7, and the second row, the even numbers 2 through 8. So the inefficient way of doing this is I'm going to make a vector of 1, 3, 5, and 7. So I have 4 of them, right? So I want 4, so 1, 3, 5, and 7. And then 4 of the evens, 2, 4, 6, 8. And then I can use rbind, okay? And then I can use by row. Okay, so I'm going to talk about how this is done, down here. Okay, so we're going to talk about it a little bit more. But let's do this. A1, A2, and then I want A to be the matrix. I want to rbind it. That makes sense, doesn't it? These look like they're rows, but don't forget, they're not. They're not rows, they're columns. So I, at first, thought, without thinking about this, I said, oh yeah, they're rows, so row bind. By row is true is fine, and I want 2 rows. Let's see what we get. Well, that's not what I wanted. I wanted a 2 by 4. I want this in the first row, this in the second row. That's not what I have. I have 1, 2, 3, 4, and 5, 6, 7, 8. How in the world did that happen? Let's take a look. Okay. So since we're using rbind, okay, we're filling the rows of the matrix. Okay. So this is row 1, this is row 2. again, we wrote the vectors as a row, but they're not rows. They're columns. Vectors are columns. So this is what they should look like. 1, 3, 5, 7 should be down here. That's the first vector. The second vector, because here's the first one, here's the second one. And I put A1, then A2. Okay? So what I have is A1 here, A2 here. And I said by row is true. So if by row is true, I go 1, and then I go over here to 2. I still haven't filled up the first row, so I keep going, 3 and 4. And that's exactly what we ended up here. So it did what it was supposed to, but that's not what we wanted. Okay? And then it's filled up the first row. It keeps going and starts filling up the second row, 5, 6, and then 7, 8. So it goes across and then down. By row means it goes across and then down. Okay? So, but I want to do by row is false. I want to go by column. If I go by column, I'm going to fill up the rows because it's an R bind. So I'm going to fill up the first row first, okay, because it's an R bind. But to do that, I'm going to go down the column. So I go 1, 3, 5, 7. And so I get 1, 3, 5, 7. And then I've filled up the first row here. And then I go to the, so I go down and then down. So across, down, and then across, and then down. Okay, so I'm going down by column, not by row. So I have by row equals false. So I've go 1, 3, 5, 7. I filled up the first row. Now for the second row, I go here, 2, 4, 6, 8, and fill up there. And that's exactly what we end up with. Okay, so that's how it's happening. I want you to understand that so that, again, you can see that I came here, copied, Control-Shift-C to get this, and then paste, and then I Control-Shift-C the next. We can also create the matrix in a much more efficient way. Rather than doing all this tedium, I can do it in one step. Okay, so I've got matrix R bind, sequence 1 to 7, by equals 2. Sequence 2 to 8, by equals 2. In row equals 2, by row equals false. I still want the false, okay? So if I run this, and then this is comparing A1 with A. It's comparing every single element. Let's see what we get. They're all true. So A1 is identical to A. It's exactly the same because all the comparison, are they equal? That's what this is saying. Is every element of A1 the same as the elements, as the corresponding element of A? And the answer is true for all of them. Okay, so this is the way to do that. So I'm going to go through how we do that. So now, in order to multiply a 2 by 4, I need a 4 by 2. If I'm going to multiply a 2 by 4, I have to multiply it by 4 by something else. I'm going to say 2 in this case. So I'm going to go through how to build this logically. So we want a column of 4 multiples of 3. So that's going to be 3, 6, 9, and 12. And we want another column of, so I can write that as sequence 3 to 12. Here's 3, here's 12, and it's by 3. A difference of 3 between each number. So I've got 3, and then I add 3 to it, then I add 3 to it, and then I add 3 to it. We also want a column of 4 multiples of 4. So I'm going to start with 4 and then add 4, 8, and then add 4 and then add 4. So it's going to go between 4 and 16. So here's what I write. I'm going to write sequence 3 to 12 by 3. Then I'm going to put a comma, and on the next line, I'm going to put, I don't need, this is just my note. You don't need that. Sequence 4 to 16 by 4. Okay. Now, what we have are these values, 3, 6, 9, 12, 4, 8, 12, 16. These are 2 vectors. Okay. So it makes sense that I want, since they're vectors, and I want to have 2 columns. Okay, this is a 4 by 2, so it's going to have 4 rows and 2 columns. That it makes sense to do a column bind. Bind the columns, cbind. Okay, so I'm typing the function cbind. Okay, now I'm going to come up and I'm going to take this and I'm going to copy it. Okay, Control copy. So I'm going to get rid of this here. We don't need that. So that was just to tell you that this error over here is okay. We haven't put it inside of anything. So what I do is I cut, but I won't do that here. I'll copy, and then I'm going to paste it inside of this, and that's what I get. I get this right here. Okay. Now you'll notice there's no error because of the comma, because I pasted that comma inside of cbind, and it needs the comma to separate this sequence from this sequence. Okay, so that's good. Now, we want a matrix with 4 rows and 2 columns. So in row is going to be, we can't set in column, we set in row. In row is 4. They may have an in column, but I don't remember. Okay, so it might be there, but I've chose to set in row equals 4. Okay, so I want 4 rows, so this is what my matrix is going to look like. I've got these blanks, and I've decided that I want to fill them by column. Okay, so it makes sense to fill them by column. I've got columns. This column of numbers I want in the first column, and this column of numbers I want in the second column. So it makes sense to go down this column and then go down this column. So I've got a cbind, and I am going to go not by row, I'm going to go by column. So if I want to go by column, then the by row has to be equal to false. And so now I'm going to write my matrix function. So what I'm doing is I'm writing matrix, enter, and now I'm going to leave the data blank, but I'm going to say in row equals 4 and by row equals false. Okay, so that's how I typed it. Okay, and then what I'm going to do is I'm going to press enter after each comma. So I've got this comma, I'm going to press enter. I got this comma, I'm going to press enter, and then I'll paste. Okay, I'll put this back the way it was. And so this is what it looks like. Now I'm going to paste the cbind statement, this statement here, without this. Okay, so without that. Okay, so let me do some undoing here to make sure. Okay, so there's that. Good. And then, so I've pressed enter after each of these, and now I'm going to take and I'm going to copy this without that, and I'm going to paste it right here. And when I do that, this is what I get. And now I'm ready to assign this matrix to object B. I'm going to call this B. So B is assigned to this, and I'm going to print it out too. So here is my code I'm going to run, and then here's B. And then I'm going to paste it, Control Shift C, and then Control V, and then Control Shift C to get that. Okay, so that's my matrix B. If you really want to use rbind, you can do it, but it really seems backwards to me. So you're going to fill up the rows first, so you need to go by row equals true. If you're going to do rbind, a row bind, then you want it to look exactly like what you've got. So if you're going to do an rbind, then you need to do by row. So you go 3, 4, then 6, 8, then 9, 12, then 12, 16. Okay? So I would not do this myself, but you may like it. And if you do, then you can do that. And you'll see that this matrix, okay, and then I can compare B1 and you'll see that it's identical, that so it does exactly the same thing. Okay. Now we can multiply A and B. So when we do this, I had a 2 by 4 times a 4 by 2. Remember, this number and this number has to be the same. And then the result is going to be this number by this number. So it's a 2 by 2. Okay. All right. And what we're doing is for each, we're doing that same vector multiplication. So we're taking, where is it? We're taking this row and we're multiplying it by this column, this first column, to get the first value. and then we're taking it by the second column to get the second value. And then we're taking the second row here and multiplying it by the first column to get this second number here. And then we're taking the second row by the second column here to get this value here. Okay? Again, I'm not concerning whether you know that or not or understand it. I'm not expecting you to be able to do this. The computer will do it for you. So I'm telling you, we could multiply A with a 4 by 3 or a 4 by anything, really. It can be as many, as long as this 4, as long as we have these numbers the same, this number and this number can be anything. Okay? So let's create a matrix C by adding a column of multiples of 5 to the matrix B. So I'm going to say I want a C bind. That makes sense. I want to add a column. So C bind B with the sequence of 5s. So this is going to be, it's always good to write these out. This is going to be 5, 10, 15, 20. There's 4 of them. So I'm going to go 5 to 20 and by 5. And so when I do that and I print out C, here is my C. Oh no, that's the multiple. So here's C. Let me put C in here. Copy. So I've already done the Control Shift C up there. Control copy. And right here, Control V. And then there. So there's my C. So 3, 6, 9, 12, 4, 8, 12, 16, 5, 10, 15, 20. Okay. Now I multiply A and C. And here is my result. Okay. So if we look at this, we had 150, 200, 180, 240, 150, 200, 180, 240. So these are still the same. We've just added these two numbers over here. Okay. So the result of the product of a 2 by 4 times a 4 by 3 is a 2 by 3. 2 by 3. 2 rows, 1, 2, 3 columns. To divide matrices, we'd have to use an inverse. And as I've said here, since matrix algebra is not a prerequisite for the class, we're not going to discuss more than the function to get the inverse. Okay? I do want to point out that vectors do not have inverses, so we cannot use matrix division on vectors. Only square matrices have a regular inverse. There's other inverses, but we won't do that. Okay? So we will need square matrices for inverse. And so the inverse is just the solve function. Now xmat was a 5 by 5. It was square. So to get the inverse, I just say solve xmat. And if it exists, it will give it to you. Okay? So what is an inverse? An inverse is the inverse of a number. So if I take, for the inverse of a number, this is the inverse of a matrix, inverse of a number. Say I have x, its inverse is 1 divided by x. So if I take x times 1 divided by x, I get 1. Okay? Well, the inverse of a matrix is similar. If I take a matrix times its inverse, I get the matrix equivalent of a 1, which is its identity matrix. This is the matrix equivalent of a 1. So a matrix times its inverse is the identity matrix. Now, so I take xmat and then times the inverse is solve xmat. Now when I do that, I want to show you what I get. I don't get what I really want because of rounding error. I get 10 to the negative 16. That means there's 16 zeros in front of this 1. Okay? That's a rounding error. Okay? So I rounded this to 4. You can do 6. You can do 10. Okay? None of these values, the negatives, are less than 16. So 16 and 17. That's the limit of the accuracy of the computer, is 16 decimal places. Okay? So even if I put 10 decimal places here, it gives me a diagonal matrix. The diagonal's 1, all the other values are zeros, okay? So, and it doesn't matter, even though I put 10, it just makes them 0, right? So I'm going to put this back to 4. And then we don't need that part. And then we copy and paste it, and then we have this. So an identity for a 5, this is the identity matrix for a 5 by 5 matrix. In matrix algebra, we use the capital I as the identity. But we don't do that usually in R. We'll call it I1. I called it I5 for the fact that it's a 5 by 5 matrix. So how do you make a 5 by 5 identity matrix? It's really easy. Diagonal 5. When I print that out, we don't need that, I get this. Okay? And then if I take xmat times I5, I get xmat. Remember, this is xmat right here. So same thing. And then if I take I5 times xmat, I also get xmat. It doesn't even look like it changed, but it did. So I'm going to put it here. See, I5 xmat. Let's see, I5 xmat. Where is xmat I5? Okay. So it did it. It just doesn't show it because of how I had this. All right. And if I take xmat minus xmat times I5, I get zeros. Okay? So is xmat equal to, I didn't finish this, here, to xmat times I5? Yes. Okay? All right. So that's it for this video. We will talk a little bit more about some matrix operations, but not too many. So I hope you will take care of yourself, stay safe. I know this video is a little long, and I apologize. I didn't want to break this up into 2 videos about matrices. So again, I apologize for that, but we'll use this as 2 days worth of videos. So that should make it a little bit easier to take. All right, stay safe. We want to see you next time.